All right, so we are the amazing avocados, and our AI model is the NeuroScan AI. So this is the video for the project. All of these images have one thing in common: a brain tumor. Brain tumors are serious, but early detection can make a big difference. With NeuroScan AI, medical professionals can speed up the process of finding brain tumors in patients. This product can save thousands of lives. So we're the amazing avocados, a team of AI camp students working on an AI model for brain tumor detection. Brain tumors are a really big problem, with a 5-year survival rate of only 36% and a 10-year survival rate of 30%. So identifying a brain tumor early on is crucial to the survival of a patient. Our AI model detects tumors within the brain scan, assisting medical professionals.
So to train this model, we use many different resources. So for backend framework, we use vision transformers and Flask to find and organize data sets. To train a model, we use Kaggle and Hugging Face. To get statistics when training the model, we use weights and biases, and we use Google Drive to store work, Google Colab to write the code for the model, and Replit to create the website.
So some challenges we had were finding categorized data sets, cropping, resizing images, and filtering out bad images to start training in a data set that was too small and an overfit model.
Sean.
Sorry, my mic was off. I was speaking. We had a 99% accuracy rate and a 0.006 training loss. The diagonal matrix line showed that most of the predictions that the AI made were true.
So for our performance and statistics, it was concluded that the model has a slight overfitting learning curve because the train loss is less than the validation loss, even though both are below 0.1. And we suspect that this is due to the small data set that we're using. If you're not completely aware of what overfitting is like when the machine is learning the algorithm begins to actually memorize the training data rather than like learning the underlying patterns. So we had a little bit of a challenge and a struggle with that.
So there are definitely some improvements we could make to the product in the future. The limitations of our time and resources meant we couldn't do everything we wanted, even the most important part. So we wanted our AI model to be able to differentiate between cancerous and non-cancerous tumors, shown right here, which they have a distinct visual differentiation. So they could tell, but the small data set that we found and we couldn't find any more meant that it was overfitting, and we couldn't get it to identify any other tumor. It also only takes in one image at a time. So if we wanted to use this in an actual medical setting for the point of it, which was to detect tumors in a large amount of photos or scans, we'd have to allow it to take in multiple photos at a time. So this is our website. So we start this title, and then we have our mission here. The purpose it talks about what the model is looking for and why we made it, which is for quickly diagnosing brain tumors in a large amount of scans. And we have the challenges, which goes over the debugging we had to do for the data augmentation, as well as making the data uniform. The process of creating the model was gathering categorized data sets, deleting unfavorable data, and augmenting the data so that the model got better at identification. We then trained it on the augmented data. The resources we used were just things like Vision Transformer, Flask, Kaggle, Hugging Face, and Google services like Colab and Drive. The statistics for our model is then listed with the accuracy and performance. We have a very high accuracy and low training loss. At the bottom, we have a meet the team, where each member of the group is listed with a photo. And then we have our demo up here. So I can put in an image, a CT scan. This one does not have a tumor. it identifies it correctly as a tumor. And if I put in one that does, it identifies it correctly as having a tumor. And these were not images it was trained on. All right. Any questions?